The iterator pattern. When we think of a custom data structure like a doubly linked list, a graph, or a tree, we will need to iterate through all the items in it. If we want to iterate through the items, a big part and problem that we think of is if all we're doing is trying to go through the items within a data structure, will we want to have to understand or know how that specific data structure is formed or the internals? This pattern is used to solve that kind of issue. We can go through those collections, data structures without having to understand or be exposed to the internals. If we look at the top code, if we're not using an iterator, anytime there's a client that has to go through a collections or data structure, it's going to have to go into the internals themselves. So if we look at the top code, it's going to know the head node. It's going to have to go specifically to the next and call the next pointer manually. And so every time it does this, it's going to go until it hits this tail. So it knows about the next pointer. It knows how the collection is formed. However, if there's some change or something that happens within the code internally, it will possibly break this piece of code. If we look at the one at the bottom, using the iterator pattern, all we have here is just the iterator that calls on these methods like reset, has next, get current, and next. And all of those are just methods on the interface. There's no knowledge of the linked list, of the next, of pointers, or anything like that. So that's where the iterator pattern comes in. The Gang of Four defines the iterator pattern as a way to access the elements of an aggregate object sequentially without exposing its underlying representation. This is a behavioral pattern. It's about how objects communicate and collaborate, not how they're constructed or composed. An insight into this is that we're just separating the collection, which knows how to store the items, and the iterator only knows how to go through them or walk through them. The client only talks to the iterator interface, and it never has to touch any of the collection's internals. A lot of times this pattern is built into the language. So JavaScript has this for of loop, and there's also this iterator protocol that follows this pattern. There's other languages like Java that has the same way that they can implement an iterator. The language has this standard iterator interface that works across all different data types. So like arrays, maps, sets, and other custom generators. For a demo, we have this structure. There's 4 participants in the implementation. We have the LRU, least recently used iterator interface, and the least recently used concrete iterator that implements it. And then we also have the least recently used cache, and also the least recently used linked list. And that is the internal doubly linked list the iterator will walk through. The key relationship that we have is the client only knows about the least recently used iterator. It never touches the least recently used cache internals, and it never sees the least recently used linked list directly. The arrow from the least recently used cache to the least recently used linked list, this is the part the iterator will hide. We have the participants table. The LRU means least recently used. This is going to explain more within the demo that we have. MRU means most recently used. If you look from the top down, the LRU iterator is that interface that we're working towards. This one just has it defines the traversal contract. It has the reset, has next, MRU, LRU, and then underneath that is the concrete iterator. It's just going to hold that current cursor, and it's going to implement all of those pointer following logic. The one underneath that the cache is the aggregate, it's the collection. This is one that stores the items, and it just exposes the get list for the iterator. That's how it can get a reference to the list, the head sentinel, without making the full list manipulation public. So it's only having access to the beginning of the cache. And the LRU linked list is the internal structure. This is the doubly linked list with the head and tail nodes. So the iterator is going to go through this, but the client wouldn't really see that. And each node within that linked list is going to be implemented by the last one, which it's going to just have the key value and the previous and next pointers. Here we have the interface. This is what interface looks like. It doesn't, notice this is what this interface doesn't expose. There's no reference to the linked list at all. Here, we don't have a head or tail, or there's no internal pointers. So the client who uses this interface can traverse the entire cache without knowing that it's backed by a linked list at all. It doesn't really have an idea of the internals. The MRU and the LRU are just convenient accessors for those extremes. They return the most recently used and least recently used nodes without moving the cursor. Everything else is just the standard traversal protocol. Reset to the start, check has next. It's going to read the get current. It's going to call the next method. Here we have the concrete implementation. And this is where the traversal logic actually exists. If we look at the constructor here, so we are creating the list from the LRU cache get list. We have the head from the list get head. And so we start at the most recently used, and we will skip the head. It calls the get list on that cache, then it calls the get head on that list. The positions are, and it positions the cursor at the head next. This is the first real data node. The head sentinel itself is never really part of that traversal. Reset does the same thing. It reassigns the current. It goes back to the head next, and that's going to be done in constant time. The retraversal is free. The next method just follows the pointer. It's going to continue on from this current to this current next. Same thing as a linked list through that one line. The has next is just a Boolean. It returns false when the current next is null. And that's the tail sentinel signal that we've reached the end of the list. And those functions, the MRU, LRU, for those, they're going to jump directly to the head next and the tail previous without even touching the cursor. Here we have the index Typescript where everything is connected together. So this is how the client uses the iterator. The collection and iterator are just created once, and then the function, the render cache, is called on every mutation. It never calls the get list. It never touches any sentinel within the linked list or in the cache. It never knows about the underlying LRU linked list. It just calls the reset, get current, and then has next for the iterator. And then also the next, the 8 lines of logic has zero knowledge of the underlying data structure. And that's the payoff that we have here. This is the demo that we have for the iterator pattern. Up here, we have the flow, where you have this least recently used cache as the collection, or the data structure. Internally, we're not trying to figure out all that's going on here. We're using this iterator to iterate through here. And this is also the internal structure that exists inside of the least recently used cache. So this is what's implemented here. So we're using the iterator to go through with the linked list, so we don't have to know all the intricacies and not having to deal with all the inner linings. If that's not very clear, this example should kind of go more into it. First, from this example, we're going to create the capacity. So from here, we're going to add a key. We have A1, B2, and C3. We're adding on to this linked list here. We're going through the least recently used, most recently used cache. This is more in detail, won't go into the intricacies. If we get the least recently used one, move it to the front, and we add another key here, then we're going to remove the last one, which was the B here, but we'll keep all of these. To try and go into detail on the demo, we are first creating the cache and iterator here, and we're instantiating these as it gets rendered here. So as we submit it in the very beginning, it creates the cache, it creates the concrete iterator. And the iterator here takes the cache that we had created here, and it takes out the list. It takes out the head here from the list, which in the least recently used cache, underlyingly, it has a linked list here. So the connection is where we are going through that internal linked list, but we are using this iterator to go through each element of the least recently used cache. Now, the biggest reason we do this is so that we can also account for these two values, the most recently used and least recently used. And from that, we're actually getting the tail and the head of the list. Without getting too much in the details, the most recently used head will be the most recently accessed node, and the tail should be the node farthest, which is the next eviction candidate. So a lot of these methods that are kind of going through the iterator here, we are just using the iterator to interact with it. Like we have the iterator has next here. We're able to get the current node here. We're able to reset to the most recently used position. So from that, we're able to just keep our place as we go down the rows through our cache and through interacting with this. If we had made any adjustments to the underlying internal structure, like the linked list here, so going back to the cache here and going back to that linked list here, going deep into this, if we did make any adjustments here, we wouldn't have to adjust that iterator because the iterator is using the get list from here to expose the list there. We're getting the head here that we're getting from here. And so because we're implementing the iterator to those methods, we're creating at least some disconnection between how we iterate and go through the cache and the underlying implementation. So anything on the higher level that we have to do, we don't have to even mess around to that linked list. We can just go through here when we have to reset it, when we have to get the current one, when we have to iterate through each and every one of these when we have to go to the next one. And when we have to render, we can reset it as well from here. So we render every node in the cache using the iterator. So this is how we create the display here using that iterator without messing with the internal structure of the least recently used cache. We want to use the iterator pattern when we have a custom collection with a non-trivial internal structure like a linked list, a tree, a graph. And we want to expose the traversal without leaking the implementation details. This is important when we want to have multiple traversal strategies over the same collection. In our demo, we could have also added a reverse iterator if we wanted to go backwards from the least recently used to the most recently used order. And this could just work over the same data structure collection without having to even touch the code at all. So that adds just another way that we could add even more complicated or different ways that we want to traverse the same collection. We can do so through iterators. It is also the right choice if we want to have a uniform interface across many different collection types. So JavaScript and Java have their own iterator way that they can, that's inside the language that can go through all of those different collection types like arrays, maps, sets, objects. They all kind of can go through the same iterator protocol. We don't always want to just use the iterator pattern because we have a collection. If the collection or the data structure underlying is just a simple array, we can just use the direct index without having to have a whole separate pattern. If we are just going in one, if there's a single traversal direction only, we don't have to have this entire pattern. We could just use a for each. And also thinking about for performance critical hot paths, this extra object allocation matters. I'm going to watch out for concurrent modifications. A live iterator plus a mutating collection will create stale bugs. So if you're navigating a collection that changes while you're iterating, you need to be deliberate about when the iterator state will refresh. There's 3 analogies that can help make the iterator pattern a little bit more concrete. The first one is we think about a playlist. A music app has an internal data structure for your songs. It could be like a graph of recommendations. Maybe it's a weighted list. When you hit play, the app will give an iterator. In shuffle mode, it's a random order iterator. In the album mode, it's sequential. So you just call next song. You don't care how the songs are stored. The second one is a database cursor. When you run a SQL query, the engine returns a cursor. You call fetch next repeatedly. The cursor might be walking an index, doing a full table scan, or streaming from disk. You don't know exactly what's happening, and you don't need to. The cursor is just an iterator over the query results. The third one to think about is a book's table of contents. The table of contents give you a structured navigation. It will jump to a position. It will advance to the next chapter. It will check if there's more. It abstracts away the physical binding. So it's kind of the same idea as an iterator. Comparing between different related patterns, the 2 patterns that we can talk about is first the visitor pattern. The visitor and iterator both walk a collection. The key difference is where the logic lives. With an iterator, you get the element and you decide what to do with it. With a visitor, the visitor object carries the behavior. So it calls the visit element, the visit method on the element, and the visitor does the work. The iterator is traversal without logic. The visitor is traversal with a pluggable logic. They're often used with each other, or they're often used together. So next you have the iterator with the composite. The composite pattern organizes objects into tree structures. You often add an iterator to traverse that composite tree. They're frequently compared. but they're solving different problems. A composite is about structure. Iterator is about traversal. If we think about in JavaScript terms, the iterator, the symbol dot iterator is the iterator pattern. When we have something like the array dot for each on the visitor, it's the visitor pattern. And the DOM tree itself is the composite. You often traverse with an iterator. In summary, the iterator pattern gives you a clean separation between a collection storage and its traversal. We have the iterator interface that defines the client contract the client depends on. It exposes zero knowledge of the linked list. And then we have the concrete iterator that implements it, holds the cursor state, and walking the doubly linked list from the most recently used to least recently used. The cache is the aggregate that exposes just enough via the get list method for the iterator to function. And the client in the index TypeScript file never touches the linked list directly. Three things to remember is that decouples storage from traversal. It hides your internals behind the interface, and then it rewinds for free through that reset method in constant time. Just all it does is reassign the pointer. If this clicked for you, you can check out the repo that I have in the description. You can play around with it. You can try and implement a reverse iterator, going backwards from least recently used to the most recently used order. You can also check out the symbol iterator protocol. This is defined in JavaScript, so this might help explain more of the iterator pattern. If you want to explore more of the patterns, I have a video and also an example of the visitor pattern. It's the same concept of traversal with pluggable patterns. And if you want to just explore all the different patterns, you can definitely try and play around in the repo, and also on the GitHub pages, you can just play around with it. I'll have the description as well. Like and subscribe if you want to see more of the patterns of TypeScript. And thank you again for watching. I'll see you in the next one.